Here we have the last part of topic 1 being about product notation. So we're looking at products of elements from a sequence given by some terms AK, and we've got AM times AM plus 1 and so forth, all the way up to AN. We're multiplying all of these terms together, and if you had a billion of those terms, then it would not be feasible to write them all up. Instead, we have this compact and useful product notation. It works just the same as for sums, and also when we're talking about generalized set operations for intersections and unions, the same sort of notation was valid there. So for instance, if we had the sequence, let's say A0, A1, A2, etc., to be equal to, let's say, 2, 5, minus 3, and so forth and so on. And if we wanted to find the product of the first 3 of these, which is of course a little bit silly, then we just say 2 times 5 times minus 3 is minus 30. But if we wanted to use the product notation, we could say, well, let's see, that's equal to the product of the terms AK, where k goes from 0 up to 2. So in other words, that's A0, A1, A2 multiplied together. So that's equal to 2 times 5 times minus 3, and that gives you minus 30. So of course, if we only have 3 terms, it's not particularly useful, but if we had a billion terms, then it would be quite useful. Now there are several properties of products. There's that if we have a product of products, so if we have this product going from M to N of AK times BK, if we have 2 sequences that we're multiplying term by term together, then that splits up as the product of the products. So this product here, where k is going from M up to N, times this product there, where we have the same terms there, except, or the same indices there, except that we have BK there. And it's a bit messy there. But you can see it in a very simple example. If we have just 2 terms, for instance, in this sort of thing, let's say A0, B0 times A1, B1, then we can shuffle the terms around to say A0, A1 times B0, B1, and you see that here's the first and the second products on the right hand side. So just by tiny little examples like that, you can see that that's probably true, and in general it's not actually hard to show. You can sort of write it out if you want, just like we did for sums. This is true, but this sort of thing is not in general true. It sometimes is. So what I'm talking about here is if we replace the product here by a sum, AK plus BK, that is not going to be generally equal to the sum of the products here, AK plus BK, where the indices are all the same, because if we mix and match multiplication and addition, then things generally don't work out. Sometimes this might actually be true, but that would be more luck than the rule. So if we wanted to convince ourselves that this is not true in general, sometimes you have equality, but that's not always the case. In fact, it's not generally the case. Well, let's try to find a very simple example, just with two terms, just like we had here. So let's say that we've got A0 plus B0. That was the first term, and the second term is A1 plus B1. And so this is the left-hand side that we're talking about. This would be AK plus BK, where k goes from 0 to 1. And if we expand this, then we get A0, A1 plus B0, B1. And at this point, if we don't go further, if we just stop here, then that's exactly what we've got on the right-hand side. But I just said that it's not usually. Well, that's because we have the other terms as well. So we have plus A0, B1 and A1, B0. So that's equal to the two products, AK and bk, those multiplied together, but then we also have these terms there. So in general, these terms will be not in the right hand side there. Bit awkwardly said. Now in this exercise, which I recommend that you stop the video and try to do for yourself, we have to simplify this particular product there. Now it's very similar to what we've seen before for sums. In fact, almost all of the product simplifications and evaluations and manipulations, calculations are very, very similar to what we've seen for summation. So we won't go through all of those techniques, but in this exercise we'll just show two methods that you could use if you get a product that you want to simplify like this. Now, the two methods that I'll show are as follows. We've seen them before for summation. The first is just simply to write out what we're dealing with. So here we have a product over some terms k over k plus 3. So we could simply just write out the terms and see what might cancel out. If we're lucky, we might get some cancellations, even a telescoping product in this case, and in fact that is what we're going to get. So where k is equal to 1, that's the first term, we have 1 over 1 plus 3, which is 4, times, and then we have the next term, which is 2 over 5, and so forth and so on, 3 over 6, 4 over 7, and so forth. And then we get down here, we have up to n, we're n over 3, n over n plus 3. So let's look at some terms before that, maybe n minus 3 for instance. N minus 3 over n minus 3 plus 3, so that's n, times n minus 2, that's the next one, over n minus 2 plus 3, which is n plus 1, times n minus 1 over n plus 2 times n over n plus 3. Okay, now if we look at the terms here, we see that there are some cancellations going on. We have 4 dividing 4 up there. We would also have 5 dividing the next one, 6 dividing the next one, etc. And down here we'd have some things that were cancelling out. This one, this one, this one would cancel out. And then we would also have n cancelling out there and leaving us with the terms 1, 2, 3, 1 over 1 plus n plus 1, 1 over n plus 2, and 1 over n plus 3. And we can write that up as n plus 1 times n plus 2 times n plus 3, all as the denominator of some fraction where we have 1 times 2 times 3 multiplied together, in other words 6. And that's the answer. So this was just by writing up in a similar way, in fact very much the same way as when we had the sum exercise where we had 1 minus a fraction and things telescoped. Here the telescoping is in terms of division and multiplication, but it's essentially the same thing. This expands and then it collapses like a telescope because of all of the cancellations. The second way that I'll show you to simplify this is as follows. We can split up this product of terms into 2 as follows. So we've got k times 1 over k plus 3. So the product of the k's times the product of the 1 over k plus 3's. And here we have to use the same k values, k going from 1 to n. And from here we could proceed, but let's just have one intermediate step to see what's going on. Here, if we write this as a fraction of the product k going from 1 to n of k, and down here we have almost something the same. We just have k plus 3. So what I've done here is replace this product of 1 over k plus 3 with 1 dividing the product of k plus 3. The reason that I did that is that now it's a bit clear that if we can somehow get these two products to look the same, so in other words, for instance, have k there and k there, then we can cancel a lot of things and we're happy. So let's do that. So we want some sort of product here to be the same sort of product there. Now, first of all, what we can do is change that k value to just be k. So we've got the product up here, which we're not changing for now, k going from 1 to n over k. And here we're going to have the product from over k, where k now goes from 1 plus 3, so that's k going from 4, in other words, up to n plus 3. So here we've got n plus 3. Okay. Now, those two products look very much similar now. We've got the same term, k and k, which is great, but we don't have the same bounds. So let's try to rectify that. So we've got a 1 and a 2 there that we don't have down there. In fact, we've got a 1, 2 and a 3 that we don't have there. So let's write them up. The first term was k equal to 1, the second was 2, and the third was 3. The remaining terms were this product here, where k goes from 4 up to n over k. And down here, we can get that product there by removing the top 3 terms, n plus 1, 2, and 3. So let's do that. So we've got n plus 1, 2, and 3 multiplied together. And the remaining product is then the product of the terms where k is 4 up to n, which is exactly this product here. So we are pretty much done now, because we see that we have this product there and this product there, they are the same. So one divides the other, they cancel out, leaving us with the remaining terms here, which is 1 times 2 times 3, which is 6, divided by these terms down there. And you might recognize those from the solution just before that we had using the first method. And in fact, they should, of course, be the same because we're talking about the same product. And there we're done. And that, dear viewers, is the end of topic 1. Enjoy the rest of the topics.